All right. Good morning, everybody, and welcome to another DMAU class. Today we're going to be going over automatic control valves, and it will be presented by Mr. Todd Schneider with Disney-McLane and Associates. Like always, if you have questions during the course of the presentation, just use the chat feature, and we'll answer each in turn at the end. And this is an ASPE CEU class. So at the conclusion as well, I'll send you your ASPE CEU certificate. So without further delay, I will pass this on to Mr. Todd Schneider.
All right, happy Thursday, everybody. Like Jim said, we'll go over some ACV, and we're going to do this more as like an ACV 101. There's a lot of ACVs out there. A little bit of past history on myself. I haven't been a rep my whole life. I was actually a contractor for roughly about 18 years. So these are something that me being in the field, I will tell you, was very intimidating. These weren't something that you just jump into. But over the last probably roughly about 6 years, I've dedicated a lot of my time to diving into ACVs, understanding how they work, understanding the operations, and really work hard to kind of simplify everything instead of making it so complicated, kind of get it simplified on how these things actually operate. And hopefully by the end, if anybody's got questions, this presentation will help you guys out. So ACVs or automatic control valves, they look extremely complicated. And like I say, for years, I'd see them and I would run away from them. I didn't want to jump into them. But overall, these are just a water on, water off valve. We're controlling either how these reduce pressures. We can do this with relief valves, sustaining valves, floating valves. We can also get into the altitude valves, which operate your water towers. But no matter how we put these things together, they're always a water on, water off, and that's how these things are going to operate. Now, throughout the presentation, you're going to see different colors. Now, I will tell you, and it's not even going to get into the exact brand, if this is a Watts or if this is Ames. This could be any valve out there, any manufacturer. They all are operating and designed the exact same way. They just look a little bit different. But what we have here is more of an LFF 115. This is going to be our pressure reducing valve. And then also, if you look over at our Ames, it's an LFM. Now, we'll tell you, they look a little different colors, but they all operate the exact same way. So just to start off, what sizes do these come in? And they will start, I know we have them all the way down to 1.25 inch. You can do 1.25 inch threaded all the way up to 24-inch flange. We can build and operate. We also are making these in stainless steel, so we can do anything that you guys need. Any sort of projects that you have out there, we'll be able to design some sort of ACV to take care of whatever problems you got. So what we're going to do is dedicate a lot of our time today more on just the pressure reducing valve end. We could spend 7 to 10 hours talking about all the different automatic control valves out there, but what I've been seeing over the last 8 years is most of these, my questions and what people are working on and designing are going to be the more of pressure reducing, taking our high pressure, incoming high pressure, and then reducing it down to a lower pressure to feed that building. So when we're looking at these valves, you see, we've got bodies, we've got all these tubes and pieces and parts. I want to kind of point out exactly what these parts are, and as we go through, we'll be going back to each one of these parts, kind of explaining what they're doing and then how important each little piece and part is. So looking at our main picture, we have our blue body. The way I explain this is just a dumb body. It doesn't do anything other than just hold a bunch of pieces, parts, and components and makes it operate. But when we're looking at this valve, we have our cover up top. When we remove this cover, what we're going to have is over in the top left-hand corner, we're going to have our top diaphragm over here. We'll have our stem. We'll have our actual shutoff valve that's internally in here, and then we're going to have a seat. But inside of this valve here, these are the main components that you guys are going to be seeing. Next one we have down here, If it's designed with a speed control, that speed control normally will be placed here in the back. We'll talk about what this is doing here. One of the other ones is going to be the pilot valve. I show the pilot valve here. It'll either look like this or look more of a brass unit. This is the brains of the whole operation. This is actually what's controlling everything on this valve is right here on this pilot valve. If you don't have this, this is just a dumb body. It just holds a bunch of pieces. Lastly is going to be up here where my arrow is, or I've kind of blown up the picture, is that's going to be our fixed orifice. Me doing a lot of sales, being outside and helping out with the service. This is also a very, very important component. It's one of the most overlooked components there. And I actually find when people are out there and rebuilding, this fixed orifice can actually get removed and thrown away because it looks, just a brass 90 that's painted red. They don't quite understand it. It's shanked off, gotten rid of, and you can easily go to any wholesaler and pick up a 3/8 flare by 3/8 IPS 90 and throw it in there. But I really talk about what this is doing and how important it is. And if you remove it from the system, how everything can kind of go haywire. So let's talk about how these actually operate on a pressure reducing system. And again, this is all water on and water off, okay? So what we're gonna do is we're gonna run into where our incoming water is heading in through our piping system, entering the ACV, but before it comes in here to open up our valve, what's gonna happen is water is actually gonna flow up through our tubing, down, and actually gonna fill this top chamber, okay? Once we fill this top chamber with our high pressure water, what you'll notice is this diaphragm is now in the down position, which is in the fully closed position. Okay, so water on is actually closing our ACVs off. Now, we're in good shape there. Let's move on to the next step. Let's see how we open this up. Okay, so what we're going to have is we have water coming through. We have water running up our tubing and then down on the cover. But now what we've done is we've opened up our downstream line, and we are now pulling water off the top of our cover, allowing water to go downstream, which now allows our diaphragm here to move up in that upper position, which now opens the valve, allowing water to flow through our ACV, up through the seat, and then down the piping system itself. So again, it just goes back to water on the valve, it's in the closed position. Water off the valve, it's now in the open position. And what we're going to be doing here is we're actually going to be regulating. We're not just going to have this thing in the full open and full closed position. We will actually allow water to go up through our tubing, down on top of the cover, also allowing water to go off, which is going to modulate this diaphragm in the open and closed position, back and forth, trying to keep that constant downstream pressure, which we're all trying to get to overall. So now that you see it, and these are easy because it's all broken down, it's open. Let's take a look at our actual ACV as everyone's going to see it in the field. And what we've got here is we have a supply pressure of, say, just for easy numbers, 100 pounds. Now, when water enters the ACV, before it opens up, what happens is water is going to run through our port, go through our strainer. Now, the strainer is going to be external, or we also have them where they're internal. All right, but it'll travel through. It's going to travel up through our tubing, across through our fixed orifice. As it drops down, we have a T, which is going to T over on top of our valve, and then also allow water to come down through and hit to our pilot valve. Now, with our pilot valve, we're going to want to set this, and we're going to say, you guys want my desired pressure to be at 75 PSI, okay? So how this is actually going to be working, hold on 1 second here, sorry. Sorry, we had somebody trying to jump in. All right, so we'll go right back. So I got water coming up my tubing through my fixed orifice. We hit our T, we got water coming over on top of our valve, pushing down in the closed position. We also run around here and water will drop down to our pilot valve, which we've decided, hey, we want this to be set about 75 PSI. So what we're going to be doing is we're going to adjust our pilot valve to 75. Anytime this pilot valve sees a lower downstream pressure than 75, what's going to happen is it'll jump in the open position, allowing water to now flow through this tube and then downstream. But what we're doing is we're actually taking it off of the top of this. Once we take it off the top, this valve will modulate in the open position, running downstream. Now, as soon as our downstream pressure starts hitting 75, this will slowly modulate in the closed position, not allowing any water to come off the top of this cover. So we'll push it down closed. No water is going to pass through, and we'll hold that set pressure downstream. Now we're going to jump back up as how do we make this? So if I put water on top and I take water off in the exact same speed, nothing's going to happen. So if I'm putting it on at 100 and I'm taking it off at 100, we're sitting neutral. So nothing's going to happen. And that's where we jump into this fixed orifice up here. What I'll do is a lot of times I'll say, hey, this is going to be the brakes. All right. And the reason I call it the brakes is we have got to allow water to come off the valve faster than we put it on. Okay. So if I'm putting it on at 100 miles an hour, I will hit my fixed orifice, which is going to slow it way down. We'll go back here. As you can see, we actually will screw a little piece inside there, which is going to bring it down to, I don't know the exact size, say like just a pinhole, but this is the brakes of the operation up here. Back to it. So we'll come up here, we'll slow our water down, we'll allow water to come off top. So now when we go to take it off the top of this valve, we're able to fly through this area and we'll hold our flow up in this direction here. So again, without the brakes, we're going to be putting it on as fast as we take it off. It'll normally just sit in whatever position that it's holding on. By adding in a fixed orifice, we're allowing now to say, hey, we're going to take it off very fast and I'll slow my incoming down. Now you say, okay, well, how do I determine how fast do I take it off? That's where we're going to come back up to our speed control. And normally what our speed control here, hit the wrong button, sorry. Our speed control will be placed up right on this side on the back side here. And then we're actually able to adjust now, how fast do I want water coming off? If I want water coming off extremely fast to open this valve immediately, that's great. But what happens is sometimes you run into like water hammer issues because this valve is opening and closing so fast. So the speed control gives us the ability to now really dial in how fast we want to take this off. So if I want it to be a slow opening, I'll adjust this to the speed control more to an out, really kind of slowing things down. If I want it fast, we're going to push it all the way in. So those are all the pieces and components and how it works. And again, don't overcomplicate it. This is really just a water on, we'll close it. A water off, we'll open it. And I will tell you that is ACVs across the board. If we're working with a pressure reducing valve, all the way down to a relief valve or even those altitude valves, it's all a water on, water off. And what we do is how we put our control pilot valves and fixed orifices and solenoid valves, allowing this water to come on and off, is how we make these valves actually work. Okay. Now, I will tell you the big one that I work with my plumbers constantly is when you're going to operate this valve. And I don't care if we're working with an 1.25" valve all the way up to a 24-inch valve. The pilot valve is the brains, and this is going to monitor what we're doing with it. When we're deciding to modulate this, just remember that we always need to run water downstream. Okay, we always have to have water. If we just decide to screw this pilot valve in and out with no water running, nothing's going to happen until somebody turns water on. And I have seen it where someone's turning this in and out and they finally just push it all the way in, say it's not working. But when they turn water on downstream, if I put this all the way in, that'll increase my pressure. So when the valve turns on, it automatically goes to its highest set point. Okay, so it's always in to increase and then out to decrease. But I always say, remember, always run water downstream when adjusting these, because if you're not doing anything, nothing's going to happen with this valve. So now we talk about, okay, we understand how they operate. We understand all the little pieces and parts that are in there. And again, different picture, but I've got my strainer. Again, our fixed orifice. my pilot valve, which my brains. Now here, right here, we've got that speed control. So this valve is going to give me the ability to slow water down where I take water off. But before I take it off, I can adjust how fast I want to do it. It's just slightly adjustable. Now, I will tell you, any valve that's out there, what I like to do is screw this all the way in, come out 1.5 to 2 turns. That's a good preset that kind of modulates in where I need to be. And then once I get water flowing, turning it on and off, I can really get into fine tuning with this one here. Okay. But you say, okay, we've got a lot of pressure. How much pressure drop can I do without damaging this valve? Now with Watts on their site, 3 to 1 is going to be the max. Okay. I think that's, pretty aggressive. A lot of times I'll drop it down a little bit more because I run into a lot where these valves have been installed. They work fine, but we're dropping a tremendous pressure. In Cincinnati, where I'm at, we have pockets that may jump up to like 200, 250 PSI, but maybe I'm trying to, keep my building at 55. That's a massive pressure drop. And when you drop these, we have such a massive drop. What we do is we end up running into cavitation, or a lot of noise. Now, cavitation, I'm sure everybody knows, but I'll just throw it out there. Cavitation is when you're trying to do such a massive pressure drop and we're trying to squeeze this water all the way down through the valve. And what's actually happening in the cavitation process is we're actually breaking down the molecular structure of the water. We're actually taking the atoms here and we're separating the hydrogen and the oxygen. And as you probably already know, once you get pure oxygen or that O2, or if you've ever heard of the ozone, ozone and oxygen is just very damaging. It gets in there, it will completely eat out the ductile body. It'll eat out all of the internal components. And what we find out is, hey, we're doing such a massive pressure drop. Say we're going from something, we'll just go with an easy one. We'll go with, say, hey, I've got 200 pounds, but I need to get this down to, below 80. So with one valve, if I take my 200, I come all the way over and I've got my 80, I'm going to come up. You'll find out that I might not be in the cavitation damage zone, but I'm in that cavitation noise zone. Okay. So in order to take it to my 200, what I'm going to do is I've got to bring it all the way down into this area here, drop down, and we're going to be more in that 85. Now, it's pretty aggressive, but it will work. If you want to do this with a single valve, we do have special components for cavitation. I will tell you, it kind of turns into a special order, a little bit of a tobacco on those. We can get everything for you, but we do make it if we have to do it in a single valve. We do have the ability to build this, but we would like to know, hey, we're going from 200. We got to get it down to 75. We're sitting in our damage zone, or we're sitting in our noise zone. We're able to jump in and basically custom make it to take care of that cavitation, to take care of, hey, we're breaking this all down, because what happens in that cavitation is we start destroying the inside of that valve. That ozone and that O2 really starts to eat out anything of the metal. And you'll see right here the cavitation damage that we've had on all these, where it literally just eats the metal out. We'll run over here where it's starting to eat this out. And all we're doing here is we're just trying to drop so much pressure that we are way, way overworking the valve. But again, it gets you back where, hey, we can do, if we have to have a single valve, we have the ability to do that by designing the system with special internal components that'll take care of that. Or we can jump into staging. And I do this a lot. It seems like in my area, it's almost like my pressures have come way up. So if I'm going to stage and I have the ability, or I have that job that I have 200 pounds coming in and I need to get it all the way down to 55, a lot of times what I suggest is using 2 valves. And what that's going to do is, instead of making such a hard drop and getting into that cavitation or that cavitation noise, which we're going to get the calls if this valve is humming a lot, you can hear it outside the walls. What I will do is actually add just a standard pressure reducing, or a standard LF F115, just our ACV, but I'm going to take that pressure from 200 PSI and I'm just going to drop it down to 85. Okay. Then once I get from 85, I will then take it and drop it back down to 55. So instead of making such a hard drop, what I do is I make just a slighter drop. And what I'm finding is we can have these valves, and these valves should be installed. They should work for, 20 plus years. We should have no issues with them if the right maintenance is done with it, if they're set up. I'm finding that, hey, if I can stage these valves and instead of bringing a hard drop, let's just do a slight drop. 200, and we could even take it from 200 down to 100, 100 down to 55, or more in that 2-to-1 ratio, staying way away from when we jump into that cavitation, which is really what's damaging and making these valves fail. Next one I run into a lot is, especially when you get into certain buildings, say such as like a hotel, where we may be feeding it with a maybe like a 6-inch valve, or maybe we're working on a school where we've got a 4 or a 6-inch valve in there, but we have that potential for like a high and low flow conditions. If we're working in, say, a manufacturing plant, normally we have a large amount of water running through, so we're in good shape. We can modulate these valves, open and close, but we've always got a large amount of water running through it, so we're in pretty good. But say, let's take for consideration, we got a hotel, okay, and say the hotel's got 100 rooms in there. We know during when everything's being run, hotels, all the water's being run in the morning and being run in the afternoon. I live in these things, so I know at 7 o'clock, between 6:30 and basically like 8 o'clock in the morning, every shower's up and running. Toilets are being flushed, sinks are being ran, but we're getting a very large flow. But after that 10 o'clock spot, we run into everyone's checked out. No one's checked in yet. So we have, the cleaning crew, they're running through, and they may be just operating 1 or 2 sinks at a time, or maybe 1 shower's running. But we run into that low flow condition between the hours of, say, 10 and 3 o'clock, when no one's checked into the hotels. Or we're working with a school, and the school, they're being used between bells, but when the kids are in class, really no water's being used. Little Timmy goes to the bathroom. He just wants to wash his hands. So, we have a large 6-inch valve feeding this school. But what happens is we're trying to, modulate this 6-inch valve with just 1 sink being ran. So what I always suggest on here is running to a high or low flow conditions. We can do this 2 different ways. You can either order an ACV with a low flow bypass already installed, which on this one here, we would have, this would be more of an LFM or an LFF 115-74, which on the back side of the valve, there will be a low flow bypass actually installed. Or this is the way I like to do it, is we're going to have 1 large ACV, which is going to control our high flow. But then what we're going to do is we're going to add an additional low flow PRV above this. Okay, now this gives me 2 great options. One, if I ever have a problem, I can now shut my ACV down and operate my building by a bypass. But it also serves a purpose where what I want to do is I don't want this large valve to operate every time a sink gets turned on. Okay, so what I'm going to do is I'm going to add a smaller valve up above. And what we want to do is we want to set our smaller ACV or PRV. We're going to set that to whatever my desired pressure. So we're just going to say with this one, I've got 100 pounds coming in. We're going to set this at 80. We're going to basically keep it right at code. So we're going to set this at 80. Okay, and the way we're going to do this is we're actually going to turn all of our control valves in the off position in the ACV. So this isn't working. I'll turn my valves on in both directions. I'll get water flowing through it. And what I'm going to do is I will start either, backing this screw out, because in the increase, out the decrease, we'll drop our 100 pounds. We're going to bring it down to 80 pounds. Once we get our 80 pounds in the set position, we know we're in good shape. We'll go up, we'll tighten our lock nut down. Then we're going to come over to our 2 valves here. We're going to shut those in the off position. Once these are in the off position, now we're going to open up our large valve. Okay. And what I'm going to do, and this is very important, is we don't want these set equally. Okay. Because if they're set equally, they're going to be fighting against each other. So what I'm going to do is I'm going to set my larger valve roughly 8 to 10 pounds below my desired pressure. Okay. And the reason I'm doing this is because during low flow situations, I want everything to run through here. Okay. But as you use water, like one sink gets turned on, now we got 5, maybe we got a few showers kicking on. My pressure, my desired set pressure at 80 starts dropping down. What I want to do now is once I start hitting that 70 or 72, my pilot valve is now going to sense, hey, I'm below my pressure. I'm going to open, allowing this ACV to open up and operate, and it's going to help satisfy the system. So now we're running through our low flow and we're running through our high flow, keeping that desired set pressure. Okay. Now I do see them where guys just throw them in and they'll say, hey, these are all preset to 50. We're in good shape. We don't want to go with presets. Okay. I always tell everybody, hey, when these get set in here, we need to operate water. We need to actually check this. And again, always set your low flow to whatever you want your desired set pressure to be downstream, and then set your main larger valve always 8 to 10 pounds below. That way we're running everything through our small valve. Once we have high flow conditions, that's really the only time that we're working our large valve. So we go back to that hotel situation between 6 and 8, 10, basically 6 and we'll say 8:30 in the morning. Both of these are operating. We're in great shape. Our 6 inches opening up. We're supplying a lot of water. But once everybody checks out roughly around 10, our large automatic control valve doesn't have to work. When 1 or 2 sinks are being ran, we're actually able to take care of the building pressure just with our low flow bypass, allowing just a smaller valve to get our pressure set where we need to be. Hopefully that helps you guys out. Now, one thing I know, and again, I travel all through roughly about 3 states, is I'm noticing that, our water pressures are getting a little bit higher, but also I'm noticing that internally, we're getting a lot of corrosion on the inside, and that's not corrosion from, a massive pressure drop or cavitation. What I'm noticing is the water's not acidic, don't take it that way, but, the water is just causing a lot of corrosion. Okay, so when we're protecting our valves, this is an investment. We're not just throwing in a little $100 valve or an $80 valve. We start getting into larger valves. We're talking, sometimes between $2,000 and $8,000 based on our size. Okay, so you want to make sure when we're looking at our ACV, we've got some sort of, we've got an ArmorTek out now, which is a newer coating on these ACVs, which is now given us more of an 8-year warranty when it comes to internal corrosion. Also, adding a strainer. If you guys have ever heard me speak or listen to any of my classes, I'm huge on strainers. And basically, our strainer is keeping all of the debris that's in our main city line from getting in and just absolutely destroying. And that can go for ACVs, backflows, mixing valves, any sort of equipment. Add in a strainer before this will honestly, it's going to double, if not quadruple, the life of the valve, because not only do we have to work with pressures up and down, corrosive water, but we also now have to deal with sand and rocks and everything else that's running through those mains. So we even have it where we can add a H strainer in the main, and we can get right before that, stop anything that's coming through. Also with the new ArmorTek coating, we're now protecting internally. So when we have these, this is the way it's supposed to look. This is what we're running into. There's barnacles, all the rust debris that's just building up. Once this epoxy coating, and epoxy coating is added to this ductile iron, to protect it, to keep that water off that ductile iron. What we run into is the water is becoming very corrosive now. In different pockets of the world, it's always going to be a little better, a little bit worse. But when we add into that ArmorTek, we're running into where we don't have to worry too much about that corrosion. These are going to be standard on every ACV that we're sending out now. And again, it gets you back to now we've got more of an 8-year warranty. And this is after a 5-year field test, same water that we had. We're able to really see that we're not running into a lot of issues with rust and the blistering in the epoxy coating coming off there. Okay, so this is something that we're now offering where we can really add in some additional protection, because again, you pay $10,000 for a valve and all of a sudden in 2 years, we open it up and it's completely full of garbage. We got, either replacing the valve or replacing all the internal parts. Now that we've added in this ArmorTek, it's really saving the lives of this valves, and we're protecting the investment, because again, if we're using this as a pressure reducing valve, if we got 100 come in, we can't send 100 down to the building. We start destroying equipment. So very, very important piece of equipment. We need to protect it. And again, some sort of ArmorTek or something, some sort of coating that is protecting internally the valve. And then please, a strainer really helps me out. That way, when we go out there, we take this apart, we see rocks. I mean, I've seen everything. I've seen wood, I've seen tools all lodged up in here. With the strainer, at least we can catch that before it jumps in the valve and just destroys everything. Again, we'll go back to what we've got internally, just a lot of buildup, debris, and corrosion. By jumping into that ArmorTek, we can really stop that. We don't have to always replace it. We can jump into, just maintaining the valve. And I do work, we do work with a lot of these, and a true preventative maintenance plan it's pretty simple. When we talk about how do we want to jump in and how do we protect this, what's my yearly, really the best thing to do is make this operate. Okay, we have it 100 coming in, and we've got 75 come out, but maybe it's been sitting in that position for maybe 3-4 years. What I tell my end users, when I tell everybody, is just get in there and operate it. My preventive maintenance plans for these are to, hey, we've got 100 come in and I've got 75. Let's increase the pressure. And we're talking for maybe 10-15 minutes. Let's screw this in. Let's bring my pressure up to 85. All right, we're getting everything working again. Then we'll bring it back down to 75 by just operating and modulating this pilot valve. We'll have open, so we're able to release the water out of the top. So if I have any dirt and debris up in this area, we're able to come up here, open up a test cock, get any of that water out of there. Also, open up the strainers, remove any of the debris out of there. Normally, I tell people do this once a year. But then after about maybe once every 3 years, maybe get in and replace our pilot. And I know nobody wants to just say, hey, let's just replace it for no good reason. But remember, this pilot's the brains of the operation. If this guy doesn't work, nothing works. So after about 3 years, I give a suggestion of, hey, let's yank the pilot off and let's put a pilot valve on. If we're getting any deeper into that, I'd say, hey, maybe every 6 years, we'll replace the pilot, and then jump in and let's replace our diaphragm. Because again, this is just operating up and down. We don't have to worry about this thing being damaged too much. If we keep the rocks and debris off the top, keep the rocks and debris up the bottom, this is a very heavy duty gasket. We should be in good shape. We shouldn't run into any issues with it. Okay, so I will tell you that these valves aren't just a set and forget about, but some minor, little housekeeping on here. And it can be easy as just letting this open and close. Maybe bring our pressures up 10 degrees, bring it down 10 pounds, and then get it back set in the right spot. So again, we can protect it internally with our new coating, and then protect this thing how we're going to operate by just making it work and making it open up and modulate. And again, if you've met me, if you've ever listened to me, sorry, I talk about the same things a lot, but adding some sort of our strainer in front of that valve. And again, a lot of these ACVs, these are controlling the building. So a lot of times, we have a backflow preventer, but this normally the ACV is collecting the first amount of water that's coming in. So we get a lot of the debris and the damage that's coming in. So adding a full-size H strainer on the main coming in is really going to be helping out our system and make this thing operate for years. Again, I'll go back to just remember when we're doing this, we always want to in to increase and then out to decrease. So I went a little quick on this one, but I want to open it up to some questions, and I'll have Jim kind of read some out, and then hopefully I can answer these for you guys.
Oops, didn't mean to do that. All right, guys, anybody have any questions? You can feel free to unmute. Okay. All right. Well, thank you everybody for joining us today. Yeah, if you got any questions after this, feel free to give us a call or shoot me an email, and we can help you out. Yeah, I hope you join us for our next class in June, going over commercial water heating. And yeah, I'll send your ASPE CEUs later today. Thanks for everybody for joining, and I hope you have a good day.
Thank you.
Thank you very much.
Thank you.